next speaker is Nicole Molinari. She'll be addressing, so Carla's talk really set us up for how complicated this situation is. And you can imagine there's a lot of land in need of restoration. So how do we prioritize this work? So that'll be the topic of Nicole's talk. She's a community ecologist with a broad interest in the consequences of human-induced global change, including the effects of wildfire, biological invasion, climate change, and altered disturbance regimes on vegetation patterns. Dr. Molinari currently serves as the USDA-Forest Service Province Ecologist for the 4 Southern California forests. That's the Angeles, the Cleveland, the Los Padres, and the San Bernardino, where she applies scientific and ecological principles to pressing management issues. Nicole received her BS in biology from Cal Poly-San Luis Obispo and her Ph.D. in ecology and evolution from UC Santa Barbara. Nicole is stationed at the Los Padres National Forest headquarters, and she lives in Goleta with her husband and 2 little boys. I'm going to turn it over to you, Nicole. Thank you.
All right. Hi, everyone. Let me get my screen going. Let's see. Okay, is everybody seeing that okay?
Yes, indeed.
Okay, excellent. All right, well, thank you, Denise, and thank you everyone for tuning in, especially on a Saturday. This is fantastic. I'm really happy to be here to recognize Carla and her contributions to post-fire restoration. This is an incredibly relevant topic at the moment, especially given the incredible amount of fire we've been experiencing in California. Over the past few decades, we've witnessed some of the largest fires in our state's history, with 18 out of 20 occurring since the year 2000. And a huge emphasis is placed on extinguishing the fires and getting the fires out before they can affect humans and infrastructure. But after the fires contain, there are people like me and Carla and many of today's speakers who are challenged with figuring out the next step for these fire scars. And this is no easy task. And it's further complicated by the fact that there's no one-size-fits-all model for understanding recovery and degradation for the diversity of ecosystems that we have across the state of California. So today I'm going to wrangle it in a little bit, and I'm going to focus on chaparral shrublands. They encompass roughly 13 million acres in California, and they provide numerous ecological and human values. Many of these are already covered by Carla in her talk. And given these values, it's notable that chaparral has been one of the primary vegetation types affected by fire, with almost 40% burning in the last 20 years. So following fire in chaparral, there's always the question of whether recovery will happen naturally or whether restoration will be necessary. So in order to answer this, we need to know a bit about the barriers to chaparral recovery. And Carla did a great job of discussing this in her presentation. But before we go there, I just want to acknowledge the amazing ability of chaparral to recover following stand replacing fire. So chaparral species, they're adapted to high severity events, and they have the capacity to rebound. But despite this ecosystem, as Carla has noted, does have an Achilles heel. Recovery can be affected by too frequent fire, and this is especially true for those species, those obligate seeders that regenerate after fire from seed, and they need time to reach maturity, establish a new seed bank before the next fire rolls in. So too frequent fire can definitely affect their recovery. Drought and non-native species, specifically non-native annual grasses, can also affect the recovery trajectory of these ecosystems. So taken together, all of these things can move chaparral away from shrub dominance and towards an invasive annual grassland. So a key task following fire is to identify areas where recovery is expected. That's the picture seen on the left-hand side of the screen, versus areas where we might expect degradation or type conversion to occur. And that's shown in the picture on the right. So we need a rapid assessment that can guide decisions about these burn landscapes. Oftentimes there's not sufficient time to sit and wait and see which of these paths, the landscape goes down after fire. It's important to get out in front of the problem. And so to help with this need, we developed a post-fire restoration prioritization tool. We call this the PREP tool. And the concept was first developed by collaborators at the University of Barcelona and the Mediterranean Center for Environmental Studies. And they developed a post-fire prioritization tool for Mediterranean ecosystems in Europe. And we adapted that tool to Chaparral ecosystems in California. And this was led by a team of scientists from UC Davis and the Forest Service. And so the framework for the PREP tool is shown in the box on the right. And that includes, as you can see, it includes the key factors that lead to impediments to recovery. So you see fire history, drought, the presence of non-native species. And then as you move down through that schematic or for that totem pole, you see at the very bottom the output. And the output from the PREP tool is a map of regeneration capacity, and it can be used to determine where recovery will likely occur naturally and where it may require more active management in order to get native species back on the landscape. So this tool was piloted on the Copper Fire, which is on the Angeles National Forest. And this is a chaparral-dominated landscape, and there was concern here for chaparral recovery. So the tool was developed, and we also did some field work to determine the ability for the tool to predict recovery versus predict areas where restoration might be necessary. So we don't have time to go through each of these steps, but I do want to point out that the PREP tool is a mapping exercise. So it pulls in spatial data from across the state. So it looks at vegetation type, and this allows us to assign a proportion of resprouters versus cedars, because we know that those two different functional types respond to fire and drought and non-native grasses differently. So we use these mapping products, and I just want to mention, for those of you who haven't looked into the mapping products that are available for California, we are sitting on some amazing data sets, and a lot of these data and these maps are produced and derived from remotely sensed imagery. And so the PREP tool is able to pull all of these together, all of this information together in a decision framework, and it functions using a point system, and then it outputs, as I said before, a map of regeneration capacity. So here's a map of regeneration capacity for the Copper Fire, and areas in red are predicted to have low regeneration capacity, meaning they could benefit from restoration, while the areas in green are at the other end of that regeneration capacity spectrum, and these indicate areas where restoration may be needed. Or, sorry, where restoration is not needed. Okay, so this is a table, and this includes the acreage and the percent of the fire scar that falls into each of these regeneration categories. And the first thing I want to point out is that the majority of this fire scar, 70%, is predicted to recover on its own. And this is a testament to the resilience of these ecosystems. There is, however, 1,600 acres, or a little under 10%, that's predicted to have low regeneration capacity. So that's a potential for a whole lot of restoration within this fire footprint. And chaparral restoration is expensive, it's time-consuming, it's logistically challenging. So it's probably not likely that we'll be able to restore this much acreage. So it's important to figure out a way to pare down these areas and develop some sort of prioritization framework to help guide where restoration should be prioritized or could be prioritized. In Southern California, we've created maps for ecosystem services, and ecosystem services is a sort of a buzzword for places where are opportunities for benefits to humans that can be provided by natural environments or from healthy ecosystems. So we can use ecosystem service data to refine where restoration could happen or could be prioritized on the landscape. So the maps on the left show some of those ecosystem services: biodiversity, carbon storage, sediment retention, and water recharge. And these are all mapped out within the Copper Fire. And any one of these layers could be used to refine the 1,600 acres that have been identified, and potentially these could be the priorities for restoration. And an example of how we could use one of these layers would be if there were concerns about soil movement affecting downslope communities, then the sediment retention layer could be used to decide where to plant deep-rooted native species. And that could help reduce soil movement and lessen the impact on communities that fires have burned nearby. So that's one way to use this information. Perhaps though, all the ecosystem services are important. And so it's possible to stack these different layers and create a single map that shows ecosystem service hotspots. And so I've done this, and this is shown as a map on the right. And the pink areas in this map show where all the services rank high. So here's a close-up. This is an overlay of low regeneration capacity areas from the PrEP tool with these ecosystem service hotspots. And so areas with high ecosystem service values, those are the areas seen in pink, and low regeneration capacity. Again, this is from the PrEP tool, and these are the areas outlined in white with, if you get really close, you can see there's black hatching there. These might be our priorities for restoration. So this is an example of how we can identify the most important places to invest in restoration and where restoration may result in the greatest good. So the final thing that I want to discuss is how we decide what to do in these degraded areas. What should our restoration targets be? This is a picture that shows a restoration project that's being led by one of Carla's graduate students, Robert Fitch. Some of you might recognize this. This is up on East Camino Cielo. And this area used to be shrubland. It's now dominated by non-native grasses, and it's in the process of being restored. For restoration projects like this, it's critical to ask whether restoration to a pre-fire condition is feasible. Is this landscape still able to support the same species that were here prior to disturbance, or have the conditions just changed too much? And one way to address this is to consider the current and anticipated future conditions and then use them to select species and to guide restoration planning. So one of the things we should be thinking about here is climate change and whether restoring to a pre-fire or a historical condition makes sense given the conditions on the ground. So if it's hotter and drier today than it was when those original chaparral species established, then perhaps we won't be successful with replanting to a pre-fire condition, simply because the landscape will no longer be able to support these species. So if we want to maximize restoration success, it will be important to take things like climate change into account. And so this is an example for how we might do that. The map on the slide shows climate change projections for a small piece of the copper fire. And the areas in red and orange are predicted to experience high and very high climate exposure by mid-century. So this is 2040 to 2069. And then the areas mapped in blue and green are mapped as climate refugia, where future climate conditions are predicted to remain suitable for chaparral vegetation. And the last thing on the map that I want to point out is that there's the black hatching, and these polygons are areas where the PrEP tool predicted there was going to be low regeneration and therefore potentially the need for restoration. So I've added black arrows to the slide, and these point to areas that have been identified as having a restoration need and also fall within areas that are predicted to serve as climate refugia. So from a climate perspective, it might be reasonable to restore to a pre-fire condition. And in the case of the copper fire, this would consist of adding species that are found within the intact parts of the fire scar. This is things like ceanothus, chamise, and manzanita. Alternatively, black arrows now point to parts of the landscape that have been identified as having very high climate exposure over the next 20 to 50 years. So in these areas, it might be wise to move towards restoration of species that are more drought tolerant. This may include species found at lower elevation or drought tolerant deciduous plants like sage scrub. And so these pictures are actually from a restoration project in the copper fire, and these sage scrub species are doing quite well. We can take a similar approach using the frequency of fire. And so this map shows the number of fires within a portion of the copper fire. And the areas in green have experienced 1 to 2 fires over the last 40 years. And so from a fire frequency standpoint or fire return interval standpoint, they're probably not at risk from too much fire. But the areas in yellow and orange and red, these have burned 3 to 5 times over the last 40 years. So they're burning much more frequently, or they have a shorter fire return interval today than they have in the past. And we should think carefully about restoration targets in these areas that are experiencing this sort of frequent disturbance. So the black arrow is pointing to an area recommended for restoration. You might have to really squint to see, but there is some black hatching over the spot. And this area has also experienced 4 fires in the past 40 years. So this is a 10-year fire return interval. So it's been experiencing frequent back-to-back fires. So this is far outside of the historic burn frequency of Chaparral. So we should question whether it makes sense to restore to a pre-fire condition. Perhaps we'd be more successful planting fast-growing species that can reach maturity quickly. And this might include native bunch grasses or using rhizomatous species that can tolerate frequent disturbance, things like giant wild rye, or potentially fast-growing shrubs that can reach maturity and produce a seed bank before the next fire rolls through. Okay, so in conclusion, the PREP tool was developed to rapidly assess the post-fire landscape. And this is especially useful in large fire scars, and we're seeing many more large fire scars every year. And in these large fire scars, it's challenging to get boots on the ground. It's hard to get people out to walk around and characterize these vast burned landscapes. Later today, however, Josie will be talking about how citizen scientists can be deployed to help with this effort. So these two things combined, the PREP tool, citizen scientists, getting people out on the ground can really help increase our understanding of these post-fire landscapes. I showed an example for how ecosystem service data can be integrated into prioritization efforts. It's also possible to use local information on wildlife use or recreational use, and this can help guide where restoration may be most valuable. Climate change and fire history data can be used to adjust our desired conditions for restoration, and they can help select appropriate species for restoration. And the goal here is to recognize that these are not static landscapes, and in order to maximize restoration success and in order to get natives back on the landscape, we may need to think outside the box. And Carla spoke about this in her earlier presentation, that we may need to move forward, but move forward in a different direction than what was there in the past. And lastly, identifying the areas in need of restoration. So basically the things I've been talking about is really just the beginning. I can't emphasize this enough. There's still an incredible amount to learn about how to do restoration. Thus far, chaparral restoration has proven quite challenging, but there are some great minds dedicating a lot of time and energy into this topic. And you'll hear from 2 of those people in the next talk. So I just want to leave you with, we're at a point now where we're learning a lot and we're getting better at this all of the time.
Nicole, thank you. That was super smooth. I like that a lot. The first thing that comes to mind is just that, we have all these challenges, but what strikes me about this is just the big data. There's so much data and so much computing power and all the sophisticated mapping that we can use to make these choices. And it made me wonder how fast is fast? How rapidly can you deploy this after a fire?
So the idea, we've used the PREP tool on about 6 fires at this point. And I will say that the first couple of fires took us a while to kind of get things going, but I now have many of these data layers processed. And the goal here is to try to run the PREP tool within 6 months following the fire, so that if there is going to be a need for restoration, that we can start the wheels turning, we can start looking for funding, we can start growing out plants and try to get in and start restoration before the annual grasses and some of the non-natives have really taken a foothold. I think that is one of the complications with our ability to restore, is that oftentimes we go into these projects 5 or 6 years after the fire, and there's really, the non-native grasses really have a stronghold in those situations. And so if we can get in earlier, we might see a little bit more success.